Okay, Algebra All-Stars. Whether you like it or not, that's what I'm affectionately calling you. Welcome to your very first lesson at home, your very first video lesson. I guess this is not really a video as it is just a PowerPoint, but it's vocabulary and you probably didn't want a video of me reading you vocabulary words. So this is a super important kind of building block, a foundation for what we're going to be learning for the rest of the semester. We need to be on the same page with the language that we're using in class so that we all understand each other, so that you understand me. When you are working collaboratively with your classmates, you understand what each other is talking about. So please be sure if at any point you need to pause this presentation, rewind, watch it again. That's the beauty of doing this at home. Nobody knows that you had to watch it 5 times to get what I'm trying to say. You don't need to be worried about other people judging you for having questions or anything like that. So use these videos. Please, please, please. This is important stuff. You know, math and algebra in particular is really, it's a cumulative practice. So you're going to take what you learn here and you're going to take it on to geometry, and you're going to build upon those skills and build upon those concepts, when you get to algebra 2 and even to trig and stuff like that. So it's really important that you are not compartmentalizing this information, that you're not just saying, well, I learned it and I took the quiz and now I can forget it. It all builds. It's a snowball. Math is one giant snowball. So we really have to make sure that we get this stuff solid in our brains so that we can move on to the next thing, but also be able to, draw back on what we learned previously in class. So we're going to start with vocabulary. Important terms you need to know. Here we go. We're going to start with a whole number. Really basic, you guys. Whole numbers are the basic counting numbers, starting with 0 and continuing on forever. So any number that you would say when you count 1, 2, 3, 4, 5, 6, 7, blah, 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 all the way up to, infinity, to a place where you really can't even count that high. It's all those numbers, but the important takeaway here is that it starts at 0. They are only positive and do not include fractions or decimals. So which of the following are whole numbers? We've got 12, 0, 17.6784, 9,999,999, 347, negative 18, and 3/5. So 12, 0, 9,999,999, and 347. Those are all whole numbers. This guy doesn't count because it's a decimal. This guy doesn't count because it's a negative, and this guy doesn't count because it's a fraction. Okay, just those whole numbers you would say when you're counting, starting at 0 and going on into the infinite abyss. Integers are inclusive of whole numbers, but also include negatives. They cannot be a fraction or a decimal. So 189, definitely an integer because we know it's a whole number. Negative 17, yes, this is an integer. It's not a whole number, but it is an integer because integers include negative numbers. Negative 19.346, nope, sorry, not invited to this party. You're a decimal. We don't want you. 290,746, yes, this is an integer. Negative 4/5, no, sir, because it is a fraction. The fact that it's a negative doesn't matter. The fraction is what gets you. All right, so that's whole numbers and integers. Expression versus equation. Really critical that you understand the difference between an expression and an equation. This is what algebra is all about. In algebra, we are trying to find unknown values. We don't really care about shapes and volume and surface area and angles and all of the very exciting things that you do in geometry. We care about the value of the thing that we don't know. That's what algebra is all about. So we are going to be given our numbers in 2 different formats. It's either going to be an expression or an equation. An expression is a mathematical statement that expresses a value and will most likely include an unknown element. You can't solve an expression. You can only simplify. And this will make much more sense when we get into like the factoring unit, which you guys are going to love. Sarcastic pause. But for right now, just understand that an expression expresses a value, but it does not include an equal sign. An equation is a mathematical statement that includes an equal sign. Equation, equal. We have all the makings of the same word here. An equation equates one side to the other, which will allow us to solve for that unknown element, which is like the cornerstone of what we're doing here. So here's an example. 3x plus 2. This is an expression. There is no equal sign. 3x plus 2 equals 9x minus 7. This is an equation. We can solve this. We can figure out the value of x because we know that this combination has the same numerical value as this combination on this side. They're on opposite sides. They balance each other. They equal the same thing. So we can solve this. Can't solve this. We can only simplify it, and we'll get to that later. Takeaway here, expression versus equation. An equation has an equal sign. An absence of an equal sign means you have an expression. Okay, variable, coefficient, and constant. When we are talking about expressions, when we're talking about expressions and equations, we are going to be talking about three very specific items. The variable is the symbol or the letter. It's always going to be a letter. Such as X or Y, that represents a value. We don't know what that value is. When we're asked to solve an equation, we are being asked to figure out what the value of that letter is. That's the whole point of algebra, solving for X or Y or whatever it may be. It can be any letter of the alphabet. I like to switch back and forth. I usually avoid using letters that look like numbers. Like I try not to use S's because they look a lot like 5s. But X, Y, any letter that you see, that is a variable and it represents an unknown value. And the sole purpose of your life when you are in room 106 is to figure out what number that variable stands for. Okay? The coefficient is the number that is stuck to the variable. In order to figure out what the variable stands for, what the variable represents, you have to get it by yourself. So you have to unstick that number. And we'll talk about how to do that when we get to the solving equations unit. But you need to know that the coefficient is the number that is stuck to the variable. You can remember that by thinking about roommates, right? Two roommates cohabitate. Coefficient, cohabitate. They live together in the same place. They're stuck together, just like that number and that variable. If the variable has no visible coefficient, then it's understood that the variable is, or that the coefficient is 1. This is something that we talked about in class when we talked about invisible math. That is an invisible coefficient of 1. If it's a negative variable, like if you have negative x plus 9, then you know that the coefficient is negative 1. Okay? And then constant. These are easy to mix up. They sound similar. They start with the same letter. But the constant is the number or numbers. There can be more than one constant in an equation. It's the number that stands on its own. So it's not stuck to variables. Let's look at a couple examples here. 7x plus 9 equals 16. So right away, the x stands out. It's the only letter here. We know that's our variable. The number stuck to the x, the 7, that's our coefficient. These two things cohabitate together. Our coefficient is 7. And our constants, 9 and 16, they're just hanging out. They aren't stuck to anything, not tied down, just living life. All right. In this second example, negative 6 minus 12y equals 18. Y is our variable. Our coefficient, is it 12? You should have said no. It is not 12. When we are talking about the coefficient, we need to take into consideration the sign that comes before it. Our coefficient in this case is negative 12 because there is a subtraction sign. That's a tongue twister. There's a subtraction sign here. So our coefficient is negative 12. Then negative 6 and 18, those are our constants. In this last example, negative 4x plus 8y minus 5, we've got two variables, x and y. This will happen sometimes. We have to solve it a completely different way than we would one of these, but by the end of this term, you will have the skills to do so, so don't worry about it. X and y are our variables. Our coefficients, the numbers stuck to those variables, we've got 8, and we've got negative 4, because we have to take into consideration that sign. And then our constants, negative 5 and 100. Okay? So variables, coefficients, and constants. A monomial and polynomial. Okay. In math, a monomial is an expression. Remember, an expression does not include an equal sign. An expression that includes only one term. A term is like a piece of the puzzle. If you're thinking about the expression or the equation as puzzle pieces stuck together, the terms are the pieces. So 4z, that's one term. It's got a coefficient, it's got a variable, but that's one term. 3xy, it has two variables, no big deal. It's still one term. So that's a monomial. A monomial has one term. Have you heard the expression mono e mono? Man to man, one to one. Monomial means one. Monochromatic, when you're wearing all the same color. Okay, I'll stop. A monomial does not include an operational sign. Okay, 2x plus 7 and 3x squared minus 12x plus 9. These are not monomials. This has two terms that are connected by a plus sign. This has three terms, 3x squared, 12x, and 9, that are connected by adding and subtracting. So those are not monomials. This is more than one term. A polynomial, we're going to use this as kind of an umbrella statement. We can kind of throw it out there whenever we're talking about a bunch of terms put together. It actually translates to many terms. The word polynomial means many terms. So we can use it, this is a little counterintuitive, but we can use it to describe a monomial, even though that's not many terms, it's just one. But in general, we're going to use it for polynomial. We're going to use the term polynomial to describe more than one term stuck together. A binomial is a polynomial with two terms. What other words do we know like that? Like bicycle, two wheels. Okay, 2x plus 7, two terms stuck together with an operation. A trinomial, three terms. Just like a triangle has three sides. 3x squared minus 12x plus 9. Three terms stuck together by operations. And then when we get higher than three terms, we'll just say polynomial. We won't say like a quadrinomial or a quintinomial. If we get bigger than three, we just say polynomial. And you will often be able to recognize these expressions because they'll have parentheses kind of defining their limits. And that's monomial and polynomial. Make sure that you know binomial and trinomial as well. Two terms and three terms. Okay, radicals and exponents. I don't want to get too into the weeds with this. A radical represents the root of a number as defined by the index. This will make much more sense when we get to our radicals unit. What you really need to know, despite this big long explanation, is that this little symbol that kind of looks like a funky check mark with a long tail, that is a radical. It represents a very specific operation. Again, we'll get to it when we get to the radicals unit. But this is what I'm talking about when I talk about a radical. It is this symbol. You will often hear me refer to it as the house. What number's inside the house? We got to get the number outside of the house. And then the index is a number that lives on the porch that tells you what root you are trying to find of that number inside. If you don't see a number like here, then it is indicating that this is a square root. But again, that's all stuff specific to the radicals unit. What I really want you to know is that it's just that cool symbol that I call the house. Okay? And an exponent is kind of the opposite of the radical. An exponent tells you how many times to multiply the base number by itself. What the heck does that mean, Ms. Thompson? It means in x squared, x is the base, and 2 is the exponent. Okay, we call this superscript when anything is written, tinier up above in the corner. That is being raised to the second power or squaring that x. And really what that means is that we're multiplying x times x. We have two x's, they're being multiplied together. So 8 to the third, or 8 cubed, 8 to the third power. 8 is the base. Oops. 8 is the base, and 3 is the exponent. This tells you to multiply 8 3 times. Well, does that mean 8 times 3? No, it does not. The answer is not 24. It means 8 times 8 times 8. We have 3 8s. The answer there is 512, which is much different than 24. So make sure you don't get those two things mixed up. The radical is the symbol that represents the root you're taking of the number. The exponent represents how many times you're multiplying the base. Like terms. Ooh, man. Okay. If you have paid attention to nothing, make sure you pay attention to this slide. If we can't combine like terms, then we are going to be in trouble from here on out. So combining like terms refers specifically to adding and subtracting. This may be the most important vocab term for you to remember. Like terms are terms that are the same. On your notes, underline that 27 times. The terms are the same. Are they similar? No. Are they like coordinating? No. They are identical. They must be exactly the same. Only when the terms are the same can they be combined, meaning can they be added or subtracted with each other. If you see a variable in an expression or equation, only the terms with the same variables can be considered like terms. 8x plus 6x can be combined to make 14x. Wait a second, Miss Thompson, didn't you just say that the terms had to be identical? Yes, I did. That doesn't mean that the coefficients have to be identical. It means that the variables must be identical or that the terms have to be in the same form. Okay, if I just had 8 plus 6, that's two whole numbers. I can add those because they're in the same form. If I had 8 plus 2/6, well, I can't add that together because they're not in the same form. It's a whole number and it's a fraction. Same thing here, 8x plus 6x, these numbers are in the same form. I can add them together because their variables match. Think about it like apples. I have 8 apples in my basket. You have 6 apples in your basket. We can put that together, one big basket with 14 apples. Okay, we can combine them because they're the same thing. 8x plus 6y cannot be combined. I have 8 apples. You somehow on our field trip to the orchard wound up with 6 oranges. I don't know where you found orange trees, but we can't put them in the same basket because apples and oranges cannot go in the same basket. It's one of the rules. All right, so those two numbers could not be added together. You would not get 14xy. That's not how it works. Okay, the same thing holds true for radicals. Only radicals with the same number inside the house can be combined. Radical 3 plus radical 3, you can combine that. These numbers match. You get 2 radical 3. But radical 3 plus radical 5 can't do it. We don't have the same number inside. And when we're thinking about exponents, can we combine these things? 8x squared plus 6x cubed? Do these things match? You should have said no. And why is that? Because they don't have identical exponents. This is getting a little nuanced, but we can even think about this as the apples example. I have 8 red apples, and you have 6 green apples. Well, we might both have apples, but we're really trying to keep the same kind of apples together, so we can't put our red apples and green apples into the same basket. Okay, the big takeaway here is that the variables or the radicals, the exponents, it has to match. They have to be identical. The coefficients, those are the things that you add together. So in this example, we added 8 plus 6 to make 14 because they had the same variables. But down here, we could not add this together. These variables are not the same because their exponents are not the same. All right, that's it. Go back and rewatch any parts of this slideshow that weren't clear. Like I said before, you guys, the cool part about watching these things at home is that you are by yourself. You do not have to worry about what other people are thinking about what you're understanding and what you're not understanding. Go back, watch it as many times as you need to. Be sure to jot down your questions in your packet so that we know how to start tomorrow's class. And you also have one more slideshow or one more video that you need to watch if you haven't watched it already about algebraic translations. But this is it, you guys. This is how we're going to roll with the class this semester. So I hope this is a helpful format for you. And if anything's unclear, make sure you write it down because we'll start class tomorrow with whatever questions you might